All right, welcome. Today, you're not just a data analyst, you're a data detective, and we're about to crack one of the most common cases in data science, missing data. We're going to get you geared up with the essential Pandas tools to find those clues and solve the case.
So let me just start by asking you this. When you look at your data set, are you 100% sure it's telling you the whole story? Or, could there be something missing, something that's quietly twisting the narrative?
Well, the thing is, there often is. There's this silent culprit that can totally skew your averages, break your machine learning models, and lead you to completely wrong conclusions. Today, we're going to unmask that culprit.
Okay, let's get this investigation started. The very first step for any detective is to really understand the nature of the crime and the suspect they're hunting down.
So, meet our main suspect, NaN. It stands for not a number. This is how Pandas flags a value that's just gone. And trust me, it is not harmless. If you just ignore NaNs, you're basically building your entire analysis on a house of cards. It's a recipe for biased stats and broken models.
Right, so the crucial point here is we can't just pretend they're not there. A good detective has to find the clues before they can solve the case. So where do we even begin looking?
Every good detective needs their toolkit, and our first set of tools is all about reconnaissance, right? It's about shining a light into the dark corners of our dataset to find exactly where that data went missing.
And here we are at the scene of the crime. This is a sample dataset of salaries, and you can see our suspect, NaN, clear as day, right there in the PhD and salary columns. This is what it looks like out in the wild, and this is exactly what we need to hunt down. Luckily for us, Pandas gives us the perfect tool for the job. It's a method called isnull. I want you to think of this as your detective's magnifying glass. It scans your entire dataset and puts a big red flag on every single spot where data is missing.
And boom, there it is. This is that aha moment. With just that one simple command, we've rounded up all the suspects. What you're seeing here are only the rows that have at least one of those NaN values. We've isolated the problem. The investigation is officially on.
Okay, so we've found our missing data. Now what? Well, we're at a crossroads, and as the lead detective, you've got a really crucial decision to make. There are basically two main paths you can take from here.
So you've got two main strategies. On one hand, you can drop it. Just completely remove any row that has missing data. It's fast, it's clean, but you might be throwing away some really valuable clues. On the other hand, you can fill it. This is more of a smart repair, where you replace the gap with a logical value. That way you get to keep the rest of the row's information.
So the big question is, which path is the right one for your investigation? And honestly, there's no single right answer. It all depends on your specific case. How much evidence can you really afford to lose versus the risk of, accidentally altering the facts?
All right, let's get back to our toolkit and see how to master the specific Pandas methods for each of these paths. We'll start with the most direct, straightforward approach.
First up is dropna. This is your go-to tool for that drop strategy. Seriously, with just one line of code, you tell Pandas, get rid of every single row that has a missing value. It is absolutely the fastest way to get a perfectly clean, but potentially smaller, data set.
And take a look at the result. Just like that. Poof. All the rows with NA are just gone. The dataset is definitely smaller, sure, but it is now 100% clean. Every single cell has a value. And for some types of analysis, this is exactly what you want.
But what if that's not okay? What if you look at that smaller data set and realize, whoa, I've just lost way too much valuable information? That's when we turn to our second tool, fillna. This is our repair kit. It's for when dropping the data just isn't an option.
Now, you have to be really careful with fillna. It's powerful, but you can get it wrong. Just look at the difference here. On the left, a bad fill. If we just stick a 0 in for a missing salary, we create a massive error that drags our average salary way, way down. But on the right, a smart fill, using the average of the other salaries, preserves the statistical integrity of our data.
And here's what that smart fill looks like in action. Check it out. The NaN values in that salary column are now neatly replaced with the mean. We haven't lost a single row of data, and our dataset's statistical meaning is still intact. Case solved, without having to throw away any crucial evidence.
So, we've explored the tools. We've talked about the strategies. Before we close the case file on this one, let's go over a few essential best practices. Think of these as the final notes every good data detective should live by.
Think of this as your data detective checklist. First, always start by running .isnull.sum to see just how big the problem is. Second, be really careful about dropping data, especially if you have a small data set to begin with. Third, think critically about your fill values. Don't just use 0 for everything. For categorical data, something like the string unknown is often a safe bet. And a final pro tip, remember axis equals 1 in dropdown targets columns. That's a common mistake that can accidentally delete an entire feature.
So there you have it. You've got the tools to investigate your own data, to find those hidden problems, and to make smart, intelligent decisions about how to fix them. You've basically learned how to be a data detective. So the only question I have left for you is, are you ready to truly trust your data?